what is a correlation between regular language and regular expression, and also we'll learn some of the theorems, that is Clean's theorem and applications, right? So application of REs, and also we'll learn some of the how to manipulating and simplifying REs, right? Manipulating means it is writing whatever the language they will give, you have to write it in a English statement or it is in the mathematical notations. So those you can be simplified using some of the identities to simplify the REs. And also we are going to learn regular grammar, and also we are writing a regular grammar writing for REs, and also writing a regular language for certain REs. Apart from this, a closure, we'll also learn some of the closure properties. There are 5 to 6 closure properties will comes. This is a very important topic in this module. 1 or 2 properties we'll be expecting for main exam. Okay. In addition to that, some of the languages are not regular. Will by seeing the language is not deciding it. You have to test them whether it is language is accepted by finite automata or not. How do you testing it? By using a pumping lemma. This topic also it is very important for exam point of view. And another point is regular language. Here it is, we are showing some of the language is regular or not, that is by using a pumping lemma. These are the major topic we'll be covering in this module. Let us start the introduction. See, translating a regular expression into finite automata is not a quite challenging. It is very easier as compared to the construction of NFA, DFA and all. First, understand what is regular expression. So first you can able to there is an expression they are given, you need to convert into the finite automata, that is possible. Okay, and also if you have finite automata, you can able to find out the regular expression and vice versa, right? So what is the major job of transforming? We have a regular expressions, so that is a input for one of the machine is called non-deterministic finite automata. Once you construct a non-deterministic finite automata, is given to the deterministic finite automata. So this deterministic automata, then you have to find the minimal state of optimized DFA. This will be the cycle, right? If you know DFA, you can able to find the regular expression. If you have a non-deterministic finite automata, you can find the regular expression. This is a cycle. Entire course is stand on this. Okay. Now let us move to the next topic, or you can see some of the example how to your regular expression is useful in your problems. Okay, there is an irregular expression, so I'll give on to the FSM. FSM is nothing but a finite state machine, which is also called as a scanner. This is expecting input as a regular expression will generate the one of the program. This in turn, this program will take the input as a string. So this string is belong to the particular class, that means it is recognized by regular language, then that is accepted, it says accepted. If that is not, particular string is not belong to that particular regular expression, then it is says no. So this way it will going to check by finite state machine, so whether the regular expression is accepted or rejected. This process is happening so before constructing finite state machine. So this is a kind of program. So it will take the input, it generate the program. In turn, this program will takes the input string as a input. That string is belong to this. Then it will say accepted or is is a valid string or it is not belong to this language, then it is a rejected or no. Let us see one of the example here. I take that is a cycle of construction here in down. Okay, in this what is the input is required here? So regular expression. So this is you have seen that is a abbreviated register specification. You might have seen this in the any electronic subject. Electronic subject from 0 to 7 the registers. How to recognize it is, you can say, one of the expressions. Either your NFA is accepting R0, R1, R2, R3, R4, any one of them it will accept it. That pipe operation is pipe symbol is indicating either accepting R0 or R1 and like that, right? So now, so these are the register names. So it will start from 0 to 9. Start with a regular expression. This is this you can call as a regular expression. Okay, this you call as a regular expression. Now how do you construct that? Is this is a regular expression. So now how to construct the NFA by using this regular expression. So one of the procedure need to use, that is Thompson construction procedure, that it will be learn how to do that. There is a separate procedure is there. In this module we will going to discuss in the third or fourth lecture class. Right, look at this one of the transition diagram I have taken directly for explanation purpose how this cycle is works. First we have taken the RE. So what is the common in that regular expression is R is the common, right? Now, so it is start with a S0. Suppose if I want to R0, so whether it is go to, it is accepting, then it will take this path. So you know already any epsilon I can be able from one state to other state while accepting a epsilon. So you can take this path and go. Suppose if I say R1 has come, it will take this path and take this is, it will go this path and so on. Okay, so now to make it is very and I1. So this is, you can see this is so big huge diagram. So I need to reduce that. I need to reduce these diagrams. How do you reduce them? So this is very important. Look at this. This is, you can say, NFA, non-deterministic finite automata. So I want to reduce by eliminating a epsilon. So look at, you'll go to the second one, subset construction build, because once an NFA is constructed, you can able to construct a DFA. That is second part of it. Look at that, which is I have seen in the previous slide. The R is common in common. So that is you have to start with R1. Then if that is a R0, so R is common for in all 9 registers. So R will go to R0. If it is R1, it will go to this path, or if it is 2, or so on like that. This is a DFA, right? So you've seen that in a previous slide there is a big huge diagram. So there is a number of states are more. As I converted into the DFA, the number of state has been reduced. Still you can make, because you have seen this when you see this diagram, there are multiple finite states. There are multiple finite states. So still you can be minimize it, because 9 final states are there. So all of them are reached to the one of the final state. How to minimize the minimal DFA? That is the last step of this cycle, right? So this is, now you can make one of all this 9 final state is merged to the single final state. So that is, so earlier you have seen in the previous few slides before that is a big diagram on NFA. There are multiple epsilon transitions are there. So then you are converted into DFA. Then DFA is still you can minimize it. So 9 state you can merge to the single state. So R is common for all the 9 registers. Suppose your R0 you want to check, that is R it is common and 0 it will accept, but one thing you need to remember, all these 9 input will not accept in one stretch. So depending on the input, it will read the character by character, so it is easy for you to construct a DFA. So this is the minimal DFA. Okay, so once you understand this concept, totally it is depending on that, so you can elaborate it. So here onwards you'll see that what is RE. So regular expression is a language accepted by finite automata is called regular language. First understand what is regular language. That is, whichever the language is accepted by finite automata is called regular language. So regular language can be described by a simple expression is called regular expression. See, any expression is described by any language is described by simple expression is called regular expression. So now why is needed here? This regular expression is a sequence of character that define the pattern, right? So it is contains some of the operators. What are these three operators? Is onion and concatenation and clean closure. There are three operators are plays important role in RE. Okay, now every RE there is an equivalent in FA with epsilon transition, as I told you. So you have seen in this epsilon transition is three previous slides, right? Now RE, as I told in the previous slide, RE as its one or more occurrence, some of the notation will using it. One or more occurrence will be indicated by operator plus 0 or more occurrence it is indicated by star operation, and all will be operated over the alphabets, right? So this is the we have seen what is RE, what is regular language, and apart from it has some operation. So formal definition of RE, it is very important with respect to exam point of view. In exam they ask for 2 marks, 2 marks, 2 marks, right? 2 or 3 marks. They more major mainly they may ask 2 marks. So sometimes they will be adjusting the questions, then the one or two marks will be increasing. So how do you define RE recursively? Look at that. There are 4 definitions are there. 1, 2, 3, 4. It can be recursively defined as well. For pi is a RE denoted by an empty set, is a kind of epsilon regular expression. Epsilon is RE, it is denoted by empty set. A is a RE, it denotes a set A. And also these have contains the zero operator. It is a basis rule. It is a basis rule, isn't it? It is a basis rule. So there is no operator 1, 1, 2, 3. In another definition, if R and S are RE, then R plus S is also a RE. R dot S is also a RE. R star is also a RE. Here it is, there are 3 operators are there. So as I told you, first 1, 2, 3 has no operator at all. Then 4 as contain 3 operators. What are the 3 operators? Plus, dot and star operators. Okay, right. Let us see some of the example of regular expressions, right? So in this you have L is equal to 0 or more occurrence of A. So how do you write that? You have to use the operation star. So let us take example. Suppose S a star 0 or more occurrence of A means first it is a any empty string is represented by epsilon. I have taken it as So there is a 1a, it may be more a 2a, it may be 3a, it may be 4a, it may be 5a, and so on, right? You can say this is a infinite occurrence of a. So how do you represent with in a RE? So you have to represent by a star. So whenever in here onwards, you need to remember whenever the regular expression has given a star, so what is the kind of string is generated? Epsilon a a a and so on, right? So this is one kind of regular expression. Similarly, we'll see one more example. L is equal to 1 or more occurrence of A. How do you represent this? Because previous example, it start with 0 or more occurrence of A. In this, there is a 1 or more occurrence of A. So 1 or more occurrence of A means plus, right? So there is a plus operation. How to represent what a kind of language is generated? Always there is no zero operator, at least 1a should be there. So 2a, 3a and 4a, like that and so on, right? It is also an infinite. How do you represent this a plus, right? So now here onwards, whenever the regular expression given as a plus, it generate this kind of strings, right? And apart from that, with that two example, we'll see what is this precedence and associativity of operators. This table is plays important role while solving simplifying a RE. So first of all, you must know that what is a precedence for these operations, right? So first I will clear it. Associativity of these three operators is left, that star has the highest precedence among these three operators, concatenation as a second one, and union as a third one. These are the three precedents need to remember. So this will important for solving a or simplifying a RE, right? We'll see this example. We'll see this example. We'll see in the next pre-video more examples on RE. Thank you. I'll wind up the pre-video now. Okay, thank you.